Hey flight simmers, welcome to the channel. I'm the Cockpit printer, and if you want to know how to build this with the usage of a 3D printer and afterwards you want to connect it to your flight sim, this is your channel. So subscribe and hit the bell. For those of you who are following this channel for a while, you will see that I'm a little bit ahead of time. This was my last project and it worked out really well with all the templates we built up in the previous episodes. And today I want to add the last bit of flavor to our panels, and this is a backlight. As you can see, the backlight changes its brightness, and once you know how to do it, it's pretty simple. And of course, you can just insert some LED strips and provide it with a constant power, but it's much nicer to have it dimmable. And there are basically two ways to do this. The first one is to use LED strips that provides the dimming function already, but then you have to deal with voltages and control the voltage that the LED strip is provided with. And the second one is Pulse Width Modulation, or PWM for short. And even if you never heard of PWM before, you are surrounded by it all day long. If you are watching this video on a computer, the fans to cool your computer are controlled with Pulse Width Modulation. If you have an Xbox at home and have a look on this little on light that slowly pulses, that is all controlled with Pulse Width Modulation. We will have a closer look how it works and how it's implemented in our environment. And afterwards we are able to add the backlight to our panels. Let's go right into it, grab a cup of coffee and let's go to work. Okay, what do we need today? Of course, our Arduino board, this panel with a potentiometer on it, and later this little servo motor. And for PWM in general, if you have a look on the board, from pin number 2 to pin number 13, there is this little PWM label, and this indicates that all the ports from pin number 2 up to pin number 13 are supporting PWM. But what's PWM actually? It's a pulse width modulation. Let's have a look on it. And here you can see a pulse is always a cycle with a specific time span. It's usually about 50 Hertz or 20 milliseconds. And the pulse is just a high voltage inside this cycle. And it's controlled by a value. The value is between 0 and 255. And 0 indicates that throughout the whole cycle there is no high state over here, it's always low. If you set the value to 63, there is this little 25%. At the beginning of the cycle it switches to the higher state, and after a quarter of the cycle it will switch back to low, a value of 127. At the beginning of the cycle, it switches to high, and at the half of the cycle, back to low, and so on. Value of 181, it's 75% of the cycle is in the high state and the rest in the low, and the value of 255 indicates that the whole cycle is in a high level. This is the pulse width modulation in general. It's very simplified, but it's just for your understanding what this pulse and the width means. There is a special pulse width modulation when you're working with servo motors. And in here, these little servos, like they are used in radio controlled vehicles and planes. Usually the cycle time is about 20 milliseconds, and the pulse itself has a minimum of 1 millisecond and a maximum of 2 milliseconds. If we are setting a value of 0, the cycle starts with a high value, and after a millisecond it will switch back to low. And the servo has very simplified. There's a little clock in there, and it measures the time span. And if it's measuring 1 millisecond, it will turn the lever to 0 degrees. If we set a value of 255, the time span will have 2 milliseconds, and the servo will set it to 180 degrees. There are special types of servo motors that have more range. Usually these types of servos have a span of 180 degrees, but there are different kinds, and there are some more types of PWM cycles for these servos. But just for your understanding what a pulse width modulation actually is. Now we are in MobiFlight, and I want to connect the LED first. And fortunately, there are two ways to add a LED, either to one of the ports, or fortunately there is already an LED connected. Right now it's a blinking LED, but we can control this LED with the usage of pin number 13. Let's set up the module. Go to the modules page, update the firmware if necessary. And let's add the analog inputs, like you can see in the wiring schematic. Analog input on A0. I will call it LED. And the second analog input on pin number A1. And another device, an LED on pin number 13. And here you can already see, here is this PWM label, and every port that supports PWM will have this label from pin number 2 up to pin number 13, and all the other pins don't support PWM. It's very nice solved in MobiFlight. You see it right away, either if this pin is supporting PWM or not. Set it to pin number 13, upload the config. Now I'm in the input configuration, add a new row. I will start with the LED. Go to the edit page, select the module and the device. And the action type, I will use a MobiFlight variable. Set it to LED. And the value, very important, insert an add symbol. And this indicates that the value from the potentiometer is stored in this variable. Hit OK. Now let's go to the output configuration, add a new row, call it LED, go to edit, And in here, the select variable type is MobiFlight variable. Select the LED, and on the display, select the LED output and enable PWM mode. Hit OK. But right now it doesn't work. The potentiometer is working right now, but here you can see the variable I assigned has a value from 943 up to 14. It's actually inverted, but it doesn't matter. And the output value is from 14 all the way up to 949. But earlier we said that a PWM signal has to be between 0 and 255. Go to the edit page, and as we did in the last episode when we connected the potentiometer to the sim, please stop here and have a look on this video first. I will add a modifier, interpolation. The minimum, the potentiometer has a value of 943. It will map to 0 and all the way up to 14 and map to 255. Now the output value is 255 and output value 0. Now this potentiometer has the output value from 0 to 255, and as you can see on the board, the LED becomes brighter and all the way back, and it switches off. And this is how easy it is to dim an LED with MobiFlight. And you can either use this input directly without the simulation connected to it, but you can also select event from the sim, like the integral light, A32NX overhead integral light brightness, and map it between 0 and 255 with this modify page, and you will dim the LED. It's really simple and really nice to do. Now I connected the servo motor to the Arduino board, like you can see in the wiring schematic, and let's connect it to the board. Right click, add device, and let's add a servo. I assigned it to pin number 2. Upload the configuration, and on the input configuration, add a new row. Name it servo input. Go to the edit page, select the module and the device, and store it in a MobiFlight variable. Servo, and don't forget the add symbol in the value. For now, I will disconnect the pin number 2 from the board. I will connect it when the input and output is correct. Otherwise, I will destroy the servo motor. Go to the output configuration, add a new row. Go to edit, select the MobiFlight variable. And on display, select the servo, min and max value from 0 to 255. You can already limit it in here. Let's check it by turning the knob. Okay, the flight sim value is not set. Let's go back to, or just run it now. Don't forget to run the configuration. And now the flight sim value, the variable from 1011 to 97, and it's inverted as well, but it doesn't matter. Let's fix this. But here the output value is from 1014 to 95. And again, for pulse width modulation, we need a value between 0 and 255. Go back to edit on the modify page, add an interpolation modifier, and from 1011 maps to 0, all the way right to 96 here, and maps to 255. Hit OK. And now I'm all the way to the right. The output value is mapped to 255. All the way left, it maps to 0. Now the output value is correct. Let's connect the signal pin and to pin number 2. And here you can see the servo is turning. Right now it's a wrong direction. If I want to change it to the direction of my potentiometer, just go back to the interpolation and either switch 0 and 255 or these two values, it doesn't matter. Hit OK. Let's try it again. And now the servo is turning in the right direction. And like the dimming of the LED, you can connect it directly to an input. Or if you want to map it to a flight sim value, instead of using this MobiFlight variable, just connect it to the sim, do the interpolation with this value, and it's very easy to connect the servos to our hardware or to MobiFlight. It's really simple. And these are just two applications of pulse width modulation. There are many more applications, like in your computer itself, the fans are controlled with pulse width modulation, for example. There are many applications for this. But in our cockpit, we will mainly use it for dimming LEDs, and we will use these little servos as well. Well, we are at the end of this video, and as you have seen, it's pretty simple to use pulse width modulation, and it's very powerful for dimming LEDs or if you want to control servo motors. If you are building a cockpit for a different kind of aircraft, not an Airbus cockpit, there are much more analog instruments, and these instruments can be built up with some servo motors and pulse width modulation. In the next episode, we will finally install the LED strips and connect it to the sim. If you are new to the channel, please subscribe, hit the bell, and see you in the next video.